The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing, this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have any questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so now we're going to look at chapter 9. And which is radicals. Our first question says, use a calculator to find the square root. Give the answer to 4 decimal places. All right, so we want the square root of 360. And apparently I've got red ink there. Let's change that to black. It just seems to show up better. Okay, so now on my calculator, I'm going to push. On mine, it's a second function, so I'm going to push the second function key and then the x squared key, which has the square root button. So second square root. And then this shows up. I'm going to put in 360 and close it up and push equals. And I get 18.973666596. But it says to 4 decimal places, which would be right there. This 6 would round up, so I get 18.9737. So let's see what happens there. 18.9737. All righty. Simplify the expression. Assume that the variable is unrestricted and use absolute value bars when necessary. Okay, so the square root of 25x squared would be 5x. However, since x is unrestricted, x can be positive or 0 or negative. And since we're taking an even root, we can't have a negative answer. Therefore, we need absolute value bars around the x. I think just about everybody missed this problem on the test. Well, not everybody, but a lot of people. So 5. Now I need absolute value. Yeah, let's see. Is it there? Ah, here we go. And there's an x. All right. Any questions about that? As I say, I think most people missed that one on the chapter 9 test. Okay. Simplify the expression. Square root of 64h to the 4th. Assume that the variable is unrestricted and use absolute value bars when necessary. The square root of 64 is 8. The square root of h to the 4th is h squared. However, even if h is negative, when you square it, it would become positive. So here you do not want absolute value bars. So we get 8h squared. If it had been just 8h, then I would have had to use absolute value bars. Okay. Simplify the expression. If a solution is not real, enter not real. The cube root of -8. Recall, you can take an odd root of a negative number. And the answer is -2. Simplify the expression. 512 to the -2/3 power. If possible, if a solution is not real, enter not real. Okay, so 512 to the -2/3 power would be 1 over 512 to the +2/3 power. Now, 512 to the 2/3 power, I could take the cube root of it and then square it, okay? So let's find the cube root of 512. And I can do that by either using, well, I'm just going to raise it to the 1/3 power. So 512 to the parentheses 1 divided by 3 power is 8. So this is 8 squared, which is 64. So this is 64. Okay, so 512 I'm going to take the cube root of it and get 8 and square it and get 64. Again, if you have any questions about what I did, you missed something, let me know. I'd be happy to go back and talk about it. All right, this says, simplify the expression. Since we're dealing with a square root, we want to break this down into factors that are squares and leftovers. The square root of 5 squared is 5 on the outside, so I get 5 times the square root of 3. Okay. Let's take a look at the next one. Simplify the expression. The fifth root of 96x to the 7th divided by the fifth root of 3x squared. We have a division problem, but the indices, the index on each one is the same, so I can write this as a single fraction under the radical. But then I can simplify 96 over 3 is what? 32. X to the 7th over x squared is x to the 5th. Well, the fifth root of 32 is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And the fifth root of x to the 5th is x. So my answer is 2x. I don't need to worry about absolute value bars since we're taking an odd root anyway. Remember, odd roots can have negative answers. All right. Find the domain of the function. When you're taking an even root, in this case a square root, the radicand, that is the quantity inside the radical, must be non-negative. That is to say positive, greater than 0, or equal to 0. So we take the radicand and make it greater than or equal to 0. Then we solve this inequality statement. So x is greater than or equal to negative 19. But interval notation would look like this. Negative 19 to infinity. And you'd have what? A bracket on negative 19 to say you include it. Parentheses on infinity because you can't include infinity specifically. Okay, so let's see here. Functions, symbols, relations, sets. Aha, okay. This one, that's the one we want. So negative 19, comma, space. Now, where is infinity? Let's see. Not there, not there. Oh, there it is. Okay. So sometimes you have to look a while to find it. All righty. Find the function value if possible. Do not use a calculator. If the answer is undefined, enter undefined. So our function is g of x equals the cube root of the quantity x minus 6. We want g of 33, which is going to be the cube root of 33 minus 6, which is the cube root of 27, which is 3. Again, I'll just keep plugging away here. If you have questions about something or need me to slow down, let me know. Simplify the cube root. The cube root of negative 64 is negative 4. Where did my mouse go? There it is. Okay. Simplify the cube root. Cube root of negative 1728. P to the 6th, Q to the 3rd. Negative 1728. If I add up all the digits, 1 plus 7 is 8, plus 2 is 10, plus 8 is 18. 3 goes into 18, so 3 goes into that. So I'm going to write this as -1 times 1728, and then -1 times 3 times, let's see, if I take 1728 divided by 3, I get 576. And 3 also goes into that. Divide by 3, I get 192. And let's see here, 3 goes into that, 64. So this is -1 times 3 cubed times 64 is 4 times 4 times 4, or 4 cubed. So basically I could write this as -1 times 3 cubed times 4 cubed times p to the 6 times q cubed. Okay, here we go. The cube root of -1 is -1 outside the radical. The cube root of 3 cubed is 3 outside the radical. The cube root of 4 cubed is 4 outside the radical. The cube root of p to the 6th is p squared outside, and the cube root of q cubed, the cube root of q cubed is q outside. So I've got -12 p squared q. Easier to do than to say. All right, so we've got -12 p squared, right arrow key, q. All right. Continuing on. Evaluate the radical expression if possible without using a calculator. If a solution is not a real number, enter not real. So we've got a negative sign in front of the 4th root of 1296. If the negative sign was inside and you're taking the 4th root, it'd be not real, but it's outside. So we're still okay. So we need to take 1296 and break it down. Oh, let's see. 1296 is 2 times 648, is 2 times 2 times 324, is 2 times 2 times 2 times 162, is 2 times 2 times 2 times 2 times 81, is 2 times 2 times 2 times 2 times 9 times 9, is 2 to the 4th times 3 times 3 times 3 times 3, 2 to the 4th times 3 to the 4th. Okay, so 2 to the 4th times 3 to the 4th. We've got a negative sign outside. The 4th root of 2 to the 4th is 2 outside. The 4th root of 3 to the 4th is 3 outside, so -6. All righty. Okay, let's take a look at this one. Simplify the expression if possible. Assume that the variable can be any real number and use absolute value symbols when necessary. If the solution is not a real number, enter not real. Okay, so we have the quantity 243 x to the 10th all to the 1/5 power. So that's the same thing as 243 to the 1/5 power x to the 10th to the 1/5 power, which is 243 to the 1/5 power x to the 10/5 or x squared. So let's see, 243 is 3 times 81, is 3 times 9 times 9, is 3 times 3 times 3 times 3 times 3, which is 3 to the 5th power, right? So I've got 3 to the 5th power to the 1/5 power x squared. So I took that and changed it into that. A power raised to a power, you multiply the exponents. What's 5 times 1/5? 1. So basically 3x squared. Okay. All right. And of course, you can go back later and look at this much more slowly if you want to. 216a cubed b cubed to the 2/3 power. So that would be 216 to the 2/3 power, a cubed to the 2/3 power, b cubed to the 2/3 power, which is 216 to the 2/3 power, a to the 6/3, which is a squared, b to the 6/3, which is b squared. Okay, now 216 to the 2/3 power would be 216 to the 1/3 power and then squared. Well, what's the cube root of 216? Let's see. 216 raised to the 1/3 power. So this is 6 squared, which is 36. So I've got 36 a squared b squared. Okay. 36 a squared b squared. All right, simplified it. Let's see here. Well, I guess if I go over time, I'll just keep going. And if you need to leave, you can leave, and you can always come back and see the stuff on the video. But I want to do as much examples as I can here. So I'm just going to keep going. All right. Negative 243, x to the 10th, y to the 5th, the whole thing to the 4/5. So that's negative 243 to the 4/5 power, x to the 10th to the 4/5 power, y to the 5th to the 4/5 power, which is negative 243 to the 4/5 power, x to the 10 times 4/5 is 45 or 8, y to the 5 times 4/5 is 25 or 4, okay? But negative 243 to the 4/5 power is like negative 243 to the 1/5 power and then raise it to the 4th power. So if I take negative 243, oops, I changed it to a 5 there. That's not a good thing. Let's clean it up here. Okay, negative 243 to the 1/5 power. That's negative 3. And then that to the 4th power is 81. So I've got 81 x to the 8th, y to the 4th. And again, I know I'm going kind of quickly. If any of you need me to slow down, please tell me. All right. 1/16 x to the 8th, y to the 8th, all to the 3/4 power. So that's 1 to the 3/4 power over 16 to the 3/4 power, x to the 8th to the 3/4 power, y to the 8th to the 3/4 power. 1 to the 3/4 power. 1 cubed is 1. The 4th root of 1 is 1. So we've got 1 over 16 to the 3/4 power is 16 to the 1/4 power cubed. The 4th root of 16 is 2. 2 cubed is 8. Power raised to a power, 8 times 3/4 is 24/4 or 6. 8 times 3/4 is 6. So we get 1/8 x to the 6th, y to the 6th. So let's see here how we're going to do this. We're going to go 1/8 x to the 6th, y to the 6th. You could also write it like this, x to the 6th, y to the 6th, all over 8, if you wanted to do it that way. Okay. Simplify the expression. Negative 125 over 64 to the negative 4/3 power. That's 1 over negative 125 over 64 to the 4/3 power. Or we could just say that's the reciprocal, which would be negative 64 over 125 to the positive 4/3 power. Maybe a little easier to follow. So then that's negative 64 to the 4/3 over 125 to the 4/3, which is negative 64 to the 1/3 power and then raised to the 4th power, 125 to the 1/3 power raised to the 4th power. Well, the cube root of negative 64 is negative 4. And negative 4, the quantity to the 4th power, let's see here, is 256. The cube root of 125 is what? 5, and 5 to the 4th is 625. So we get 256 over 625. Let's see, 256 over 625. Okay. You know what? I'm going to skip this one because it's going to be the same thing, same idea. You're going to rewrite it as 64 over 9 to the positive 3/2 power. Let's go down and do this one. 1 over 4 to the negative 5/2 power would be 4 over 1 to the positive 5/2 power, or just 4 to the 5/2 power, which is 4 to the 1/2 power raised to the 5th power. Square root of 4 is 2. 2 to the 5th is 2, 4, 8, 16, 32. Use a calculator to evaluate. So we're going to have parentheses 53.5, little caret power key. Actually, let's see here, caret, and then parentheses 1 divided by 4. Technically, I don't need that first set of parentheses, but I do need one around the 1/4, so it'd be 53.5 and then 1 divided by 4 in parentheses, the power key. Okay, round to the nearest hundredth. I get 2.7045. So it'd be what? 2.70 as before, rounding down. 2.70. Okay. Simplify the expression. Square root of 75. I could break that down as 25 times 3, the square root of 25. It looks like the same answer we had in a previous problem. Maybe, I don't know. 5 square roots of 3. Maybe it was just similar. Okay. Simplify the radical expression. All variables represent positive real numbers. That means we don't need to worry about absolute value bars. 162 is 81 times 2, which is 2 times 9 times 9, which is 2 times 3 times 3 times 3 times 3, which is 2 times 3 to the 4th power. So this is 3 times, not 3, 2 times. Slow down. I was getting in a hurry and then I start making mistakes. I'll bet you know about that, don't you? Okay. So this is 2 times 3 to the 4th times x to the 12th times y to the 4th. That's not going anywhere. The 4th root of 3 to the 4th is 3 outside. The 4th root of x to the 12th is x to the 3rd outside. The 4th root of y to the 4th is y outside. and I've still got the fourth root of 2. Okay, so I've got 3x cubed y, and then now I've got to be careful because I want the fourth root of 2, and this only allows me square roots. So I've got to find something where I can put the here it is, where I can put the index in. So the index is a 4 and inside is a 2. That's another little detail that people sometimes miss. I've had people ace the test except for that one little detail. They forgot to put the correct index in. Okay, don't let that be you. Okay, here we go. Square root of 242, simplify the radical. 242 is 2 times 121 is 2 times 11 times 11. So this is 2 times 11 squared. Okay, the 2 is going to stay inside. The square root of 11 squared is 11, so I get 11 square roots of 2. Simplify the radical. All variables represent positive real numbers. We can take a quotient inside a radical and write it as the quotient of 2 radicals. So on the top I get z, on the bottom I get 2x. Since they all represent positive real numbers, I don't have to use any absolute value bars. So we've got z over 2x. All right, simplify the expression. The square root of 720 over the square root of 5 is equal to the square root of 720 over 5, which is, let's see here, what do we get if we take 720 divided by 5, 144, and the square root of 144 is 12. Okay, this one's basically the same. I'm going to skip that one, go on to this one. 27, simplify by combining like radicals. Square root of 32 minus the square root of 98 minus the square root of 128. Well, 32 is 2 times 16. Square root of 16 is 4, so I get 4 square roots of 2. 98 is 2 times 49, so 2 times 49. Square root of 49 is 7 outside, square roots of 2 inside. And 128 is 2 times 64. Square root of 64 is 8 square roots of 2. So you get 4 square roots of 2 minus 7 square roots of 2, which is negative 3 square roots of 2, minus 8 square roots of 2 is negative 11 square roots of 2. Okay. Negative 11 square roots of 2. Okay, let's see. I'm going to skip that one. It's very similar to the one we just did because I want to get through this as well. Solve the equation. We've got the square root of 6x plus 45 equals 9. Solving a radical equation is kind of like solving an absolute value equation. If you've got one radical, you want to separate it. It already is. So then the next step is to square both sides. So we get rid of the square root on the left and we get 81 on the right. Subtract 45 from both sides. 6x equals what? 36. Divide by 6, x equals 6. Let's check our work. This would be what? 36 plus 45, which is 81, and 9 equals 9. So it checks. And the next problem, we've got the square root of 5x plus 7 equals 2. So again, we want to isolate the radical. Now we've got a square root equals a negative number. So that's not going to work, but it says to write all proposed solutions. So we'll square both sides and we get 5x equals 25. So we get x equals 5. So that's a proposed solution. But if we plug that in, it doesn't work, which means it's extraneous. So that doesn't work. Extraneous are solutions that you get, but then they don't work. And finally, we've got the cube root of quantity x plus 1 equals negative 1. We've got the radical isolated. We're going to cube both sides in this case. And then subtracting 1, x equals negative 2. Let's check it out. It checks. Negative 2. All righty. And it's a 12:29. Class is supposed to go till 12:30. By golly, I made it. So before I stop the recording, do you have any other questions you want to look at this point? I'm guessing not. All right. So I'll stop the recording.